All right, so welcome to the podcast to Philip. And today we're doing a deep dive into something really kind of surprising.
Yep.
It's about how AI models and specifically Anthropic's Claude model really work. We're all like wowed by ChatGPT 4.5, Gemini 2.5, Claude 3.7, Alibaba Quinn 2.5, Baidu Ernie X1.
Right.
All these new AI models are coming out.
It's an explosion.
Yeah, and the weird thing is they're creators.
Yeah.
They don't even really know how they work.
Yeah, they don't.
Like inside.
It's a black box.
Yeah, it's like a black box.
And we're just seeing what comes out.
Right, so we're going to like...
And it's amazing stuff.
It is amazing stuff. But we're going to like peel back the layers.
Yeah, we're going to look inside.
On Anthropic Claude model using this method they call circuit tracing and see what we find. And also, we are trying to hit 1,000 subscribers on YouTube today.
Oh, wow.
So if you could...
That'd be fantastic.
Hit that button.
Yeah, subscribe.
That would be amazing.
It would really help us out.
So Anthropic's approach with this circuit tracing...
Yeah.
It's pretty unique, right?
It really is. It's like, you know how in neuroscience, they use brain imaging to see what parts of the brain are lighting up when you're doing something?
Yeah.
It's like that for the AI.
Wow.
They can actually directly observe what's happening.
They can see the decision-making.
The pathways as Claude is processing information, like which components are active and which ones are not.
That's amazing.
And they can even like manipulate those components to see how it affects the output.
That's crazy.
Yeah, it's really wild.
So this circuit tracing...
It's like having a microscope for the model's decision-making process.
Right.
You know?
I like that analogy.
Yeah, Joshua Batson from Anthropic, he used that analogy.
Okay, yeah.
And it's really apt because it's like you're zooming in on these really intricate processes and you can see the nuts and bolts of how it works.
So that's different from previous methods because it's like looking at...
Yeah, previously they could only really
the whole thing.
Look at smaller models or like very specific circuits.
Right.
But now with this, they can analyze multiple circuits in a large complex model like Claude.
That's cool.
Yeah, it's a game changer.
So what did they find? What did they find when they looked?
Oh, they found some really surprising stuff.
Yeah.
So one of the first things that really blew their minds was that Claude plans its responses in advance.
Oh.
Like they thought it was just going to be like word by word, generating text. But
you're just like reacting.
It's not. It's actually thinking ahead.
Wow.
Like they gave it a task to generate some poetry, and they found that it was considering how the line was going to end much earlier in the process.
Wow. So it's like it knows.
Yeah, like way before it even got to the end of the line.
Like the whole like flow of the poem or something?
It's planning it out.
Wow.
Yeah, it's not just reacting.
So that's some foresight.
It's thinking ahead,
yeah,
which is crazy.
Yeah, that's so cool.
Yeah.
So it's not just planning, but it's also like flexible.
Yeah, it's super flexible.
Like in its planning.
Like they did this experiment where they intentionally disabled a component that Claude was using for rhyming.
Oh, so they like messed it up?
Yeah, they broke it.
Yeah.
And you'd think, okay, well, it's not going to be able to rhyme anymore.
Right.
But instead of just giving up, it rerouted.
So it like adapted?
It found a different component to achieve the same result.
That's so cool.
So it still rhymed.
Wow.
But it was using a totally different part of its brain to do it.
Yeah, it's like working around a problem.
Exactly.
That's amazing.
It's like problem solving.
Yeah.
Like it's got this ingenuity.
That's so cool.
Yeah.
So we've got the planning, we've got the flexibility. And then the other thing they found was about how it processes different languages.
Oh, yeah. This is wild. So they asked Claude the same question in English, French, and Chinese.
Okay.
What is the opposite of small?
Okay, yeah.
And what they found was that it doesn't have like separate modules for each language.
Okay.
It first activates these language independent components.
Oh, so like...
To understand the concept.
Understands the concept first.
Like the meaning of opposite and smallness, and then it engages the language-specific components to formulate the answer.
In the right language.
Yeah. It's like it's thinking in this abstract conceptual space and then translating it into the language that we understand.
Right, so it's got like a central like meaning processor.
It's a shared conceptual space where meaning exists before it's translated.
That's amazing.
Yeah. And what's really cool about this is that it suggests that learning in one language can be applied to another. Oh. Like if it learns something in English, it can use that knowledge. Yeah.
When it's working with French, or Chinese.
Yeah, that's huge.
It's like this universal language of thought.
Yeah.
It's really mind-blowing.
So that's really cool. But then they found this weird thing.
Oh, yeah.
With the explanations.
Yeah. This is a bit of a head-scratcher.
Yeah, like the explanations Claude gives don't always match up with what's happening inside. Like they gave it some simple math problems.
Right.
And it would explain its solution using
standard arithmetic.
Yeah, like normal methods. But then when they looked at the circuit tracing...
Yeah, they saw it was taking a completely different path to get to the answer.
Wow.
Yeah.
So it's like
it's learned what a plausible explanation sounds like.
Right.
But it's not actually using that method.
So it's mimicking human explanations.
They think it's mimicking the explanations it's seen in its training data.
Right.
So it knows what we want to hear.
Yeah.
But it's actually doing something else.
Yeah. That's so weird.
It's really weird.
Can we even trust the AI then?
Yeah, it raises some big questions about the reliability of AI explanations.
Right.
Like, if it's not actually reflecting how it's making decisions, then what are we even looking at?
Yeah, how do we know what it's really doing?
Yeah, it's a bit unnerving.
So this circuit tracing also showed how Claude handles, like, complex multi-step reasoning. Like, it's easy to think that these models just memorize tons of information.
Right.
But it's not just that.
It's more than that.
Right.
They asked it, what is the capital of the state where Dallas is located?
Okay.
And they could see Claude activating these intermediate conceptual steps.
Oh.
Like first, it recognized that Dallas is in Texas.
Okay.
And then it accessed the knowledge that the capital of Texas is Austin.
Okay.
So it wasn't just recalling the answer.
Right.
It was actually putting those pieces together.
Yeah. It's like combining information from different places.
It's reasoning.
Yeah. And to test this, they did a really cool experiment.
Oh.
They artificially changed Texas to California in their internal representation.
Okay.
And guess what happened?
What?
Claude's answer changed from Austin to Sacramento.
Wow.
Yeah, so it wasn't just memorizing the answer. It was actually combining.
Like if A, then B.
Yeah.
Yeah.
It was using logic.
Wow, that's so cool.
Yeah.
So all this is really interesting, but
yeah.
Anthropic says this is just the beginning.
Oh, yeah, totally.
Yeah.
Like Joshua Batson said, this is just the tip of the iceberg.
Wow.
Like they're only seeing a small percentage
right.
of what's actually happening.
It's like a glimpse.
Yeah, tiny glimpse.
Into this huge complex system.
Mm-hmm.
Right.
And right now it takes forever to trace even short queries.
Really?
Yeah, hours and hours of work.
Wow.
So to analyze more complex requests,
right.
they're going to need much better methods.
Right, yeah.
They even suggested that AI itself might be needed to speed up the analysis process.
Like AI? To study AI?
Yeah.
That's crazy.
It's getting meta.
Yeah.
Yeah.
So we've learned a lot about Claude and how it works.
Yeah.
And it's way more complex.
Way more.
Than I think we ever imagined.
Yeah, we're just scratching the surface.
Right.
But it's really exciting.
Yeah, like the planning.
Yeah.
The potential for this universal language of thought.
Mm-hmm.
And then this weird thing with the explanations not matching up.
Yeah, that's a big one.
Yeah.
Like, what does that mean for our understanding of AI if it's not telling us the truth about how it's reasoning?
Yeah. And then, like, what happens as AI gets even more sophisticated?
Yeah, that's the big question. Like, are we going to be able to keep up?
Yeah.
Are we going to be able to understand it?
Yeah.
And control it?
Right.
It's a bit scary.
Yeah, it is.
But also really fascinating.
It is.
It's like we're on the verge of something huge.
Yeah.
And we don't even know what it is yet.
Yeah, we're just starting to figure it out.
Yeah.
So what do you think? What do you think all this means for the future?
I don't know.
It's a big question.
It's a big question.
Yeah.
But it's one that we need to start thinking about now.
Yeah.
Because AI is not going away.
It's only getting more powerful.
Yeah, and more integrated into our lives.
Right.
So we need to understand it
if
we want to shape its development in a way that benefits humanity.
Yeah, that's a great point.
So yeah, I think this research from Anthropic, it's really important because it's giving us a glimpse into the black box and helping us to understand how these AIs are really thinking.
Right. And hopefully we can use that knowledge to build a better future.
To create a future where AI is a force for good.
That's a great note to end on.
Yeah.
Thanks for joining me on this deep dive.
It was my pleasure.
It was awesome.
Yeah, it was fun.
And we'll see you next time.
See you next time.
All right. Bye.
Bye.